All right, everybody. So we are on 41 through 60, EOC Practice 41 through 60, and there's some interesting problems in here. I mean, each set is very different from the previous. The previous one had a lot of domain and range on there, and this one, not so much. It's got a lot of, this one actually has some conics on there, all right? We skipped the chapter on conics completely, although conics are a little bit on the ACT, so I'll probably hit them a little bit at the end of the year. They're not on the EOC at all, so I did skip them for now. Mr. Miller and I decided that that was the best way to go. So we are on EOC Practice 41 through 60. I'll probably do it in two sections, 41 through 50 and then 51 through 60. And the first problem is a doozy. We're not going to do this one. We're going to do strategy here. This one would take a long time. I don't know a quick way to do it. When you think about it, all it's saying is, so we've got this triangle that's at 2, 1, about right there, 4, 4, about right there, and 6, 2, about right there. It asks which system of inequalities describes the interior. So whatever this line is, less than, whatever this line is, less than, whatever this line is, greater than. That would describe the interior. Basically, it's a system of inequalities. But none of them are in y equals form, and we don't even know which one, goes with which line easily. Now we can figure out the line between those two, and the line between those two, and the line between these two. That would take quite a while. So I'm going to call this one not an efficient use of time. I know how to solve it. I can explain it to you. We're skipping it. Number 42. What is the solution set of this system of inequalities? There's a whole lot of systems of inequalities on this, and it is almost all calculator work. For a system of equations, not inequalities. For a system, you plug one of the equations in y1 and one of the equations in y2, and you see where they cross. So you're looking for intersect, okay? Intersect can be a little tricky on some problems. So this one we're plugging in. Remember, you got to get it in y equals form because you're plugging it into y equals, right? So y equals negative x squared plus 1 and y equals x plus 1. One of them is an upside down parabola, and one of them is the red line. So we're going to use second trace or the calc menu. We're going to go down to number 5, intersect. And it's a little tricky with intersect, so you gotta kind of play with it a little bit. There's two intersections there, even though they're hard to see. You want to get kind of to the left of one of them, and then hit enter 3 times, and it tells you what that first point is. -1, 0. So we're definitely looking for -1, 0, which is unfortunately in this one, and this one. At least we can cross D out, okay? Now the other one, we go to second trace and it's intersect, and it's a left one. No, we already did the left one, I was backwards. We're gonna go to the right. So when it asks for the first curve, I'm going to go to the right of that right-hand intersection and then hit enter 3 times. And it's going to give me a weird number for x. I don't know why the TI does this sometimes. It gives you a weird number for x. That is an incredibly small number. For some reason, it calls it 0. So we're going to call that 0, 1. And our answer ends up being C. All right? Moving on, number 43. Another solution to a system of equations. So, no problem. We are going to get them both in y equals form. The first one would be y equals x plus 3. Second one's a little trickier, okay? I'm gonna rearrange it a little bit. I'm gonna kick y, 7y over here, but then I'm gonna reverse it on you because I like my y to be on the left. So my 7y would equal x squared plus 31. Divide everything by 7. And y would equal this, okay? So the best way to type that in is y equals 1/7 x squared plus 31 over 7. I'm using that alpha x a lot so that I get fractions and I don't have to use so many parentheses. And I don't have to worry too much about order of operations, okay? Use that alpha x a lot. And then the other one's just x plus 3. We'll graph it. We'll see what they look like. One of them is just sort of the bottom of a big parabola, and the other one is a line that cuts through in 2 spots, even though it's hard to see. We're going to ask it where it intersects. We're going to go left, left. There it is. 2 comma 5. Yeah, 2 comma 5. Yeah, I don't have my glasses on. 2 comma 5 is, it's either one of these. Let's find out where that other intersection is. Actually, I can see it. It's definitely not 5 comma 2. It's definitely 5 comma 8. So I saved a little bit of time by just looking at the point and looking at my calculator. Okay? So, answer is B on that one. And there it is. 44, what's the solutions? Another system of equations. You're got to get used to these guys because they are definitely going to be on there. So, let's solve it. We're going to get this in y equals form. Y equals, I'm adding y to both sides, adding 3 to both sides, and then reversing it. Sorry if I do a fair bit in my head. Honestly, less than some of you do. I just try to save time, okay? Equals 2x squared plus 2. And that should solve it for us. We're going to plug both of these in. X squared plus 3 and 2x squared plus 2. See what they look like. Should be 2 parabolas, actually. It is. It's 2 parabolas, kind of one inside the other. That's okay. We're still going to ask it where it intersects. This is one of the weird ones where I'm just going to go kind of to the left. I want to get close to that intersection and hit enter 3 times. -1, 4. Okay, so it's in that one, and that one. We can cross off B. Let's find that was the left-hand intersection. Let's find the right-hand intersection. Again, I'm going to just scroll over to the right to where I'm a little past that intersection, just so that it knows which one I'm asking for. And it is 1 comma 4. So we're going to go with D on that one. There it is. All right, 45. We're at 7 minutes, 50 seconds. We're doing great. How many real roots does this have? Oh my gosh, the roots are where it crosses through the x-axis, right? Right, everybody? Right, Hunter Bowen? Exactly. That's where it crosses through the x-axis. It doesn't cross through the x-axis. 0 roots. That was easy. Which number is added to both sides to solve? This one's also easy if you remember how to complete the square. And I know that is it's kind of a minor skill. It was back there when we were doing solving quadratic equations. You can solve quadratic equations by factoring them. You can solve quadratic equations by graphing them, and you can solve quadratic equations by completing the square. This is the one where completing the square is where we left some room after that linear term. And then put the plus 3 over here. Actually, normally we would kick the plus 3 over there, but it doesn't matter too much. And then to complete the square, we take half of that and square it. And we do that to both sides. So 16 is the number that we would add to both sides. So the answer to that one is B. We don't have to solve it. That's what's nice about this one. If you read it very carefully, we don't have to solve it. We just have to add, we just have to find out what we need to do to complete the square. And the answer is add 16 to both sides, so B. All right, 47. What is the solution? We're talking quadratic formula. They should all look very familiar. So we're just going to go ahead and solve it. Negative B plus or minus the square root of B squared minus 4A is 1, and then C is -3, all over 2A. Rewrite, keep rewriting, right. 25 plus 12 is 37, -5 plus or minus the square root of 37 over 2, and I'm done. -5 plus or minus the square root of 37, so B. All right, quickest way to do it. What is the y-intercept? Y-intercept is where it passes through the y-axis. It doesn't matter how complex the function is. The y-intercept is just where it passes through the y-axis. So, we can graph it. Let's graph it and see what it looks like. Clear both of my former graphs. Type fairly quickly because we're always in a little bit of a hurry. Not a hard panic hurry, but we're always in a little bit of a just sort of getting the answer as quickly as possible hurry. Looks like +1. Zero, 1. We're going to go with B. Yep. Obviously, not obviously, but another way to do this one is any point on the y-axis, x equals 0, right? So this point's 0, 1, 0, 2, 0, 3, 0, -1, 0, 2. So we can plug in 0 for x, and we end up getting y. So if we plug 0 in for x, y equals 1. So that point would be 0, 1. Another way to solve that. All right, 2 more. What are the coordinates of the minimum point? You should recognize this as a quadratic. You should know that that's going to be a parabola. We can plug it right in our calculator. It's asking for the minimum. So the minimum is going to be the vertex. Well, that doesn't matter because the calculator, it speaks the language. So it's going to tell us, we're going to ask it for the minimum. Go to the left of the minimum, hit enter, go to the right of the minimum, anywhere to the right, hit enter, and it's going to look for one between those boundaries. And it says 1.99999. I don't know why it does that sometimes, but the answer is 2. 2, -1. So we're going to go with C on that one. Okay? And last one. Which one represents the graph? All right. Obviously, we could just graph all of those. It wouldn't be super quick. Or we could remember that it's flipped over, so A is definitely negative. So that crosses off that and that, because both of those would go up because A is positive. So there's our 2 possibilities. Both of them pass through 0, -2. That's the y-intercept. So there's that point. So that fixes both of them. Now we just got to figure out which one of these, -1/4 or -4, gives us sort of this wider, sort of bowl-looking one, instead of like the normal one or a skinny one like that. And the answer is, I don't know. I always forget. Does a fractional A make it wider or skinnier? I think it makes it wider. I think bigger numbers make them skinny. But here's what we're going to do. Because I don't know and I don't remember and I want to get this one right because I'm so close to the answer already, I'm going to find a point. There's a point right there. It has to be like an exact point. So I'm going to find that point right there. 2, -3. It has to be an exact point. It can't be one of these in the middle. And then I'm going to see which one plugs into this thing real quick. So -4x, or you know what? Quicker than that probably would be just to go ahead and since you only have 2 to graph now, go ahead and graph those 2. But I'm going to follow mine. So -4, if I plug 2 in for x, 4, -16, that does not give me -3, but I'm going to make sure this one does. 4 times -1/4 is -2, -1 times -2, get my bearings crossed here, is, so we're going to go with A on that one. And if you were to graph it, you'd see the same thing. Okay? There it is. All right, great. We're at 14 minutes, so I'm going to start a new video.